Hello guys, welcome. On today's tutorial we are going to look at the modified normalized difference water index. So it's actually an improvement on the should I call it the conventional NDWI, whereby we use this modified version on in built up areas, right? Good. So where we have this urban kind of settlements. So we have some satellite imageries here that runs through bands 1 to band 6. Now when you download, yours will be bigger than this because this has actually been clipped to a particular study area, right? Good. So yours will be the complete tile, or if you have also clipped it to your study area, that's good. So we have clipped it to a study area and then we have them in their bands from band 1 to 6. So for us to use it to calculate, we go to Raster and then we click on Raster Calculator. On the Raster Calculator window, we are going to write the expression. So we open a bracket. So the expression is actually green minus the shortwave infrared divided by green plus the shortwave infrared. So for the satellite imagery we are using, which is Landsat 9, the bands we are going to use are actually bands 3 and band 6, where band 3 represents the green and then the 6 represents the shortwave infrared. So we have the formula to be, as we have opened the bracket, band 3 minus band 6, and then we close the bracket, divided by, we open another bracket, we have band 3 plus band 6, and then we close the bracket, right? Good. So now this is the expression that will be used to extract the water bodies in the built up area, right? Good. So let's save it. So we have then we click on save, then we click on OK. Good. So we have the values extracted for where the water bodies are dominant, right? Good, or visible. So we are going to change the symbology. Double click, come to symbology, select single band pseudo color, and then we use quantile, and then okay, because of this color range, because of this color ramp rather, I'm going to invert this our color ramp because blue should actually represent water. So I go to invert color ramp, and then maybe I can just enhance this blue. It's not completely blue. Maybe just make it look bluish, and then maybe let me just give a sharp contrast, and then make this about red. Okay, let's see how that goes. And then okay, the 5 classes are okay depending on the number of classes you want. The mode is quantile, and then we can just apply. Good. So the symbology has indicated that these areas or these regions that are having blue coloration are places where we have the presence of water, right? Good. So moisture, water, as the case may be. So now let's just stick with this symbology for the meantime. Now the next thing we would want to do is to turn on a base map. We have the Google Hybrid, and then we also have the OpenStreetMap, right? Good. So now let's see the Google Hybrid. You know, basically the Google Hybrid is kind of near recent, right? Good, near real time. One is actually on ground. So these regions where we have identified water, let's actually see if on the base map it's actually okay. You can see that there are water bodies around there, and then if we decide to bring on the OSM, which shows the water body in blue, you would also see a shade of blue rather. You would also see that these regions that have been extracted to be water bodies are actually predominantly water, maybe ponds, rivers, and the case may be. Now before we leave, we are going to do a binary extraction, kind of a thresholding. You know, we have a range of values from minus 0.6 to positive 2.7, right? Good. So we know that the range of value is from 0 to 1, or maybe from minus 1 to 1, as the case may be. If we now have this value, we want to look at from this our custom, that's from the values we have, from what value upward can we say indicates the presence of water, and then we are going to isolate the other range of value. So since we are having 0.6 minus 0.6 to 0.272, So we are going to say the values that are ranging from maybe 0.05 upwards should indicate the presence of water. Now that is dependent on the range of value we have here. So if we come back to Raster Calculator and then we bring in the modified NDWI, then we write an expression that says when the NDWI is the values actually greater than 0. We have 0.05, right? Good. So we save that. So we have that as water and then we run. Good. So we now have zeros and ones. If we still come back here and then we change this to single band pseudo color, maybe making it equal interval, make it 2 because we just have two classes. You can see 1 and 0. 0 means absence of water, so let's make that a bit red. And then 1 means presence of water, so let's make that blue. And then we click on OK, apply, and then we click on OK. So this now shows just water and every other land use within the urban area as we have on our study area. So we have shown you how to calculate the modified normalized difference water index, and then also how to use a threshold. Maybe yours can be different, but the idea is that okay, it can even be a longer expression, but the idea is that we just want to extract regions where we know that the values that we have, the numerical indicator that we have, is closer to a particular value, or maybe from that value upwards, as the case may be. Right, good. To now see that there is a presence or absence of a particular land use, in this case water. So we are going to see you on the next one. Until then, keep staying safe and have a fantastic time. Bye.